figure P2.3-1, the signal G1 of t is equal to G of minus t. Okay, here if you look at this one is G of t and G1 of t, and as you see G1 of t is equal to G of minus t. It's because time is reflected in the negative about the y-axis because of this negative sign. Okay, that's an example given, and also they're asking express signal G2 of t, G3 of t, G4 of t. Like this one is G2 of t, this one is G3 of t, G4 of t, G5 of t in terms of signal G of t and G1 of t. So we had to use these two. We had to use this one and this one to express this four of them, and they are time shifted, time scaled, or time inverted version. Okay, so we just have to worry about time shifted, time scale, and time inverted version. For instance, G2 of t is equal to G of t minus capital T plus G1 of t minus t. This is some example like how you can bring these graphs using some shifting for these two signals. Okay. And something like that, and also for some variable similarly both G3 of and G4 of you can express something like you can adjust by putting negative sign. If you put a negative sign, and that is shift right to by t units, and if you put positive sign, it shift left by this t number of units. So for some suitable value of t, and G5 of t can express as G of t time shifted time scale, then multiply by a constant. This operation may be performed in any order. Okay. So let's try to express G2 of t. This is the graph we have, and if you look at this, the first part of this graph looks exactly similar to G of t, but the thing is it shifted one unit to the right. So we had to do the shift for the G of t to make this one happen. Okay, so we can say G of, okay, let me use a different color. G of t minus 1 G of t minus 1, that is G of t minus 1 is G of t shifted right by 1 unit. Okay, and if you shift G of t right by 1 unit, it's gonna look like, let me so initially it was at -1 starting. So if you shift 1 unit to the right, now it's gonna start at 0, and the value that we had at 0 is going to move to 1. So this is going to be 1 here, and this is going to be 0, and the height remains the same, that's 1. Okay, this one is G of t minus 1. We just shifted G of t 1 unit to the right. Now we have to do the same thing for the G1 of t. G1 of t, if you compare this one, G1 of t and this signal exactly look same, but only difference is this one shifted 1 unit to the right because it's starting from 1 and this is 0. So if we shift G1 of t 1 unit to the right, we can get this one. So G1 of t minus 1 is G1 of t shifted 1 unit to the right. Once we shifted that, okay, let's also call these names. Let's call this graph as number 1, and let's call this one, if you shift this one, this is going to look like Now let's say this is 0, this one is 1, and initially it was starting at 0. So if we shift right to the 1, so this gonna start at 1 right now, and then the height is 1, and it's gonna be here at 2. So this one is 1, this one is 2, and this height is 1. Okay, and let's call this is g1 of t minus 1. Let's call this graph number 2. Why I'm naming this like this number is because we may use this later if we have similar thing. Okay, so what is the g2 of t? Now we have brought the two components that is similar to this. Now we have to add them together to make that happen. So 1 plus 2. This is 1, this is 2. You add them together, that is g2 of t. So g2 of t is basically g of t minus 1 plus g1 of t minus 1. And that is basically it. Okay. And the graph again is gonna look like this. This is the graph. Let me put a star for here so you can. Okay, so this is the graph. If you want, you can just draw it one time. Okay, this is the graph, and this one is 0, height is 1, this one is 1, 2, and this is same height. Okay, so now we have taken care of g2 of t. Now the next thing is g3 of t. Go to new page. g3 of t. Okay, let's look at that. Okay, g3 of t graphs like this. And is there anything similar to what we had in the g2 of t? No, because this one, okay, we have one similar, like the first one is similar. We can use this. That is the first equation we have, g of t minus 1. Okay, we can use this one here because this one exactly look like this part here. Okay, so we can use that. And for this one, we don't have anything till now. Okay, so what we can do, we can, if you look at the g1 of t, it looks exactly the same. But before we used the g1 of t, but we shifted 1 unit to the right. But here we had to shift it 1 unit to the left because it should be starting at -1. So let's do that one. So g1 of t, g1 of t plus 1 is g1 of t shifted left by 1 unit. Shifted left by 1 unit. Okay, so if we shift the g1 of t left by 1 unit, is gonna look like this. Initially it was starting at 0 and going up to 1. It was at 0 and going till 1. Now it's going to start at -1 and go 0. Okay, This one is -1, this one is 0, the height is 1. And this one is g1 of t plus 1. Now we have the two components that's needed to make this graph happen. We have g1 of t plus 1, that is this, and we have g of t minus 1, that is this part. So if we add them together, so that is basically 1 plus, let's call this one 3, 1 plus 3. 1 plus 3 is g3 of t, and that is equal to g1 of t plus 1 and plus g of t minus 1. Okay. So this is the answer for the g3 of t. Now let's look at the next part. Next part is we have a unit step function. Here we have ramp functions, but here we have a unit step function. But the question says use g1 of t and g1 of t and g of t to express this graph. And also we had to just you do the time scaling, time shifting, and what else we had to use? We have inverted versions, time inverted versions. So we don't have to do anything else since they didn't mention anything ramp or anything else. So we don't have to worry about converting this one into unit step function. We have to just consider the shift and if the height changed somehow. So we don't have to do basically anything except shifting the graphs. So here we have a minus half, starting at minus half, and then plus half. Okay. You know what? We can actually make this happen. How can make this happen? Because if we move this one by half unit to the right, this one is gonna be meeting at half right here, right? And if I move this one actually half unit to the right and this one half unit to the left, this is gonna meet in the middle as well. The middle we have both of them half, and these two add up and become one. So this still works. We don't have to do anything else. So to make that one happen, we had to just move both of them half unit to the right and half unit to the left. So which one to the right? T of t to the right, because here if you see, if I move this one only to the right, then only I can have it this one at negative half. And if I move this one to the left, then only I can have this one at positive half. Okay, let's go ahead and do that. Okay, so g of t minus half, g of t is this graph. I'm moving this one half unit to the right. G of t minus half is g of t is shifted right by 1 over 2 units, and the graph is going to look like here. This is negative half, and this one is ending at positive half. Okay, and then we are gonna have this is, let's call this one number 4, and then we have to move g1 of to half unit to the left, so g1 of t plus half, and this one is g of g1 of t is shifted left by half unit. Okay, if we left g1 of t left by half unit, this is g1 of t. Well, if left by half unit, it's gonna look like starting at positive half and then goes up to negative half. Okay, goes up to starting at positive half, goes up to negative half. Okay, wait, I'm moving this one by half and that one. Okay, I made the first wrong because g of t, if I move half unit to the right, this is going like this. So let me here draw this one. This one is basically like this. Okay, so now it makes sense because when we add these two together, you see this is a ramp function and this one also ramp function, but both of them are opposite side. For example, imagine this. We have this one here and we have the other one over here going like this, and if we add these two together it should fill up like this. Okay, initially it wasn't added, but when we add it should fill up like the square like. Okay, for example, like here we have both of them half, we add half and half, this become, and let's say if you take a point like this, let's say this is like 0.25, that time this is 0.75, 0.25 plus 0.75, that add up. That's how we get a square. So if we add 4 and 5 equation, let's close from 5 and the height is 1 here, and if we add 4 and 5 we get 4 plus 5, that gives us the equation for the g of 4. So g4 of t is basically g of t minus half, g, it is g of t minus half plus g1 of t plus. Okay, that's the equation. Now we only have the last part left. We have to find out the equation for this. Okay, so last one. Initially we have what do we have here? We have exact function that looks like the function that look like the shifted version of g of t, that is g of t minus 1, like this, right? We can use that one right here. So we can use g of t minus 1 over here, and the g of t minus 1 is a graph that is shifted, g of t graph that is shifted 1 unit to the right, and the height of the graph is 1, and then this is 0, and distance is 1. Now, according to, if you look at the graph, we want to derive the height is 1.5. To make the height 1.5 happen, you have to do an amplitude scaling. That is, basically you have to multiply the function by 1.5. So if I do that, the new height of the function is going to be 1.5. This is basically 1.5 g of t minus 1. For that one, the height is going to be 1.5, and it's going to still go up to 1. So this is 1.5, 0, and this is 1, and this one is 1.5 of g of t minus 1. Now we have to do one more thing, because if you look at here, the graph is ending at 2, but here the graph is ending at 1. To make this graph ending at 2, we had to do time scaling as well. So to do the time scaling, what we had to do is we had to do we had to put a value in front of t that will make this one to do that. We had to put 1 over 2. Like if you want to make this distance 2, you have to do 1 over 2. If you want to make the distance 3, 1 over 3. If you want to make the distance half, then you put 2 here. So it works opposite time. Like if you put 2, it's going to become 1 over that, and if you put 1 over 2, it's become 1 over 1 over 2, like that's 2. So you have to think in opposite way. So if I put this one, like if I um 1.5 of 5 g of 0.5 t minus 1 is 1.5 g of t minus 1 expanded by long time interval, long time interval 0 to 2. Okay, so here now we are going to have the graph that is starting at 1.5 height and 0, and this one is 2, and that's the graph we want. And this one is 1.5 t 0.5 t minus 1. And for this graph we don't have to add or do anything, because this is just a one graph. And if we do the amplitude scaling and time scaling, it's gonna bring the graph we needed, so we don't have to do anything to add or anything. So the answer for the g5 of t is basically this expression, 1.5 g 0.5 t minus 1. And that's our answer for this part, g5. And that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.